Good morning, everybody. I know it's early in the morning, so hopefully everybody had a good night last night. I'm surprised to see more than 10 people here, so it's happy to see that. Look, I'm going to take a step back. In the last couple of presentations, and most of the presentations here, you look at more of the global picture. You look at the numbers of the different projects. All of those numbers at the end of the day need to be made viable. And the way that you actually start making all of your projects viable is by looking at the actual production side of things, looking at the small things, looking at improving efficiencies. So the two things that I'm going to be looking at is, with information technology becoming available, we've all known that geostatistical analysis and geology models, etc., have been available for over 30 years. Now lately we've got, with the advent of laser scanners, we can actually start bringing all of that information together, and that is what I'm going to be focusing on. So I'll be looking at bringing that information together and sort of looking beyond the rock face. I remember about 15 years ago when I just started, I was sitting underground, if anybody is familiar with the underground environment, especially on the survey side of things. And I was doing my survey thing, installing line pegs, etc. And I had one of the mining guys come and stand next to me. And he stood there for a couple of minutes just looking at me at what it's all about. And eventually I just turned back to him and I'm asking him, well, is there anything I can do for you? And he said, well, can you actually tell me where the ore is just by looking at your machine? I'm like, no, you can't do that. And that was 15 years ago. And we probably joked about it a couple of times. And now, 15 years later, I actually realized that what he was thinking, we can actually start doing now. We can start bringing that information that we've modeled up, geology, the geosciences, we can actually start combining that with your laser scanning environment. As I said, we can now start working with your geology environment. The mining is going to be changing in the next, it's changing every year. Everybody understands that last year was a tough year for the mining environment, so we start looking at finding ways to improve your efficiency. So we've got a lot of data that we can start using it, and the way that we start utilizing the data in different ways is how we start improving the efficiency. So we look at the rapid execution of daily tasks. When you were a surveyor 10 years ago and you had to go and survey an open pit, sometimes it would take you a day, couple of days to get detailed information. With laser scanners nowadays, you can start doing that and get a model out in a number of hours. So that couple of days, it's not there anymore. Also, improved accuracy. You can start getting 10 centimeter accuracy, sub-millimeter accuracy, which wasn't available many, many years ago. With that improved accuracy, the reporting side of things, the reconciliation side of the mining, what has been planned, what is actual, we can start improving on that as well. And also, it's just modernization as well. It takes something that's taken a long time, 10 years ago, and just modernize it a little bit. And then we want to start combining that virtual world of all of this data that's sitting in space, and we actually start combining that with the laser scanning side of things. So, as I said, the geology has been around for about 30 years. Everybody understands that if you want to build up a mine site, you go and drill a couple of holes, there's your holes, you build up a geological model of it, you do the geostatistical side of it, and if you think about the geostatistical side, you've got your kriging, your inverse distance that everybody is aware of, everybody knows how to use that. So now you've got this spatial 3D model of your ore body. If you start going and you start scanning areas and you start putting these two together, what you've got is it provides you a model where you can actually physically see a face and you can actually start seeing what's happening behind that face as well. And we need to start finding a way of combining these technologies. Previously, it wasn't possible for us to do that. Reason? Well, computers couldn't manage that. If you had to start modeling up millions and millions of point computers 10 years ago, they probably would have just laughed and your computers would not have worked. Nowadays, the graphics environment and the processing power allows us to actually start doing this. We can actually start visualizing what has been modeled up from a geosciences with the actual scanning areas. And the advantages of that is we can start updating our models. So previously we might have required in-pit drilling. Now we can actually start using the scans, and we can start updating your geological model as well. One side benefit of using scanning data, it provides you that safety aspect as well. If you don't, sometimes you do not want to have, you're not allowed, for safety reasons, to approach a bench, approach a face. You can now safely scan that from a distance, 100 meters away, 500 meters away, up to a kilometer away. That information can be used in various departments. It's not just for historically surveyors that can use that. I can have that information being used by geotechnical department. I can start using that in the mine planning department. I can start using that in the survey department, which it was originally done for. So you can start overlaying your photos, as I said, with taking that information to a geotech, and he can start digitizing and start drawing up his own images, start creating up a geotechnical database just by looking at photos. There's almost no need for him to actually go out to a site anymore or go out to the pit anymore, and he can start doing that on his own time. One of the main reasons why we have this improved accuracy, or the requirement of having this improved accuracy, is also your mining plan. So I've planned, I'm going to be mining a certain bench, and I've found that, well, the areas that I've mined, it wasn't like that in my short-term model. Now I can just go and scan up, I can go and use the data, and I can update my model with the newly acquired data. With new technology, there's always a question, but does it work? How do we know that it actually works? And then you start going into how is this regulated? So laser scanning technology is slowly but surely being accepted as part of the regulation process. So what we did a couple of years ago, we can now with confidence go and say it is approved, it is regulated. And just one example that I'm going to be using quickly is just Rehabilitation Monitoring Australia. So what they've actually started doing is they've started taking their photographs and started taking their scan data and creating an image, creating a 3D model. If you had to go and create a 3D model of a rehabilitation area, a couple of years ago, you didn't have the accuracy, you didn't have the point cloud density to actually start modeling this up. So now that you've got this extended accuracy, you can take a scan on the 1st of January this year, you can take a scan on the 1st of January next year, and the information you can get from that is valuable to anyone that wants to start identifying, for example, your erosion. How much actual material has been eroded away in the year? Is my rehabilitation program working? You can start calculating how much my flower has grown. So the environmental people start saying, well, actually, the plan that you've put in place, it is working. How do we measure that? Nowhere we can actually start physically measure whether rehabilitation works. We can do that now. We can calculate, I have lost an X amount of tons in erosion over the year. Maybe I need to have a look at my rehabilitation plan again. And also you can start doing the landfill monitoring. You can start distinguishing between the different rock types. Like I said, also the plant growth. You can start looking at your erosion depth. If you just have a look at specifically, if you can imagine that this is what it looks like this year, and last year it might have looked completely different. Have a look and see where the problem is, and see if you find a way of solving that. And then also ultimately just basic tools like checking your slope angles, etc. So, just in conclusion, it's a step forward in what you can do and what you can achieve now. Bring all of that information together is what you want at the end of the day. Technology will continue to be accepted by the regulation. This year, something it was, we've got all of these standards, this JORC standard and SAMREC standards, they came about being something that we can measure it against. Laser scanning is moving into that environment as now, that it is actually being accepted. And people are going to continue to find innovative ways of using technology. I know that there's some examples of laser scanning being used in police, like in crime scene investigation, where they start scanning an area and they can remodel this whole area, and then that's kept in the archives. 10 years later, they can actually review the whole area. Okay, thank you very much. If anybody's got any questions, you can come and see us at 1403. Thank you very much.